Every single day, human beings consume over 1 billion hours of video on YouTube. Managing a library of that magnitude requires a matching engine capable of parsing infinite human preferences in real time. Grounding this digital abstraction reveals a massive physical footprint. Google's server architecture provides the immense computational density required to instantly catalog, process, and serve millions of distinct video files to nearly 2 billion logged-in users every month. The platform's 2005 launch targeted the online dating market, utilizing the slogan, "Tune in, hook up." Desperate to populate the empty site, the founders uploaded mundane clips, including a simple 19-second shot standing in front of elephants at the San Diego Zoo, just to observe how people would interact with online video hosting. The server logs revealed that users were ignoring the dating profiles and instead utilizing the infrastructure for self-broadcasting. The founders adjusted the business model and opened the upload pipeline to any video type. Data-driven behavioral correction is the foundational DNA of the platform. The algorithm acts as a constantly evolving mirror of human preference, adjusting its output based on how audiences interact with the content. Prior to 2012, the system's objective function focused on raw click counts. This incentivized creators to deploy deceptive tactics, securing an initial view, but resulting in immediate viewer abandonment and poor retention rates. To solve this retention problem, YouTube partnered with Google Brain. Google Brain is the company's dedicated artificial intelligence research team focused on deep learning. Together, they replaced the simple view counter with a superior objective metric, watch time. This split-screen visualization compares the two models. On the left, the pre-2012 system generates a sharp spike in clicks, followed by a steep crash as viewers realize they've been tricked. On the right, the watch time model produces a sustained area chart, rewarding content that actually keeps a user's attention. Rather than serving users identical cloned videos on a loop, the deep learning AI prioritizes adjacent recommendations. It plots pathways to related but distinct topics to keep users on the platform. This pivot shifted the platform's objective toward maximizing long-term satisfaction and total session duration, creating a system that rewards sustained engagement over the initial click. Before a human ever clicks on a video, it must be indexed. The first step in this intake pipeline utilizes Cloud Vision to scan the video's thumbnail. Cloud Vision is a suite of machine learning tools that automatically analyzes and classifies images. Optical character recognition evaluates the thumbnail, extracting text and discrete objects. The system cross-references these identified faces, objects, and text arrays against billions of data points to generate precise confidence scores, calculating whether the image is safe for general advertisers or requires restriction. The analysis then moves from the static thumbnail to the moving video file, engaging Google's Video Intelligence, an API that automatically recognizes objects, places, and actions moving through stored video frames. Video Intelligence scrubs the file frame by frame. It generates automated shot lists, labeling environmental contexts, brands, and physical actions to build a deep visual profile. The final extraction layer operates on the audio track, using natural language processing on the closed captions. This branch of artificial intelligence allows computers to interpret, manipulate, and comprehend human language. By diagramming sentence structures, natural language processing extracts the exact semantic context of the dialogue. It can easily differentiate between a dry scientific biography of a physicist and a satirical comedy sketch discussing the exact same person. The AI does not blindly host a video file. It actively watches and reads the content, building a complete, highly accurate semantic profile of the video before a single recommendation is ever made to a user. That semantic profile is only the primer. The real predictive power of the engine is driven by the 80 billion behavioral data points generated by human users every day. This circular diagram illustrates the intake of satisfaction signals, like long-tail retention or saving content to a playlist. The system weighs these against negative signals, like immediate skips or short view durations, forcing the output pathways to instantly recalculate and shift recommendations. Because the deep learning machine is built to mimic biological neural networks, it makes nonlinear conclusions. It identifies patterns across these conflicting signals that human analysts could never spot. The system relies on these aggregated behavioral metrics to prioritize content, focusing on user-validated satisfaction over individual creator status or genre. A common misconception among creators is that a single universal algorithm dictates the success or failure of all videos on the platform. In reality, the central feedback loop feeds into multiple distinct sub-algorithms. Each traffic source operates under its own rule set. This network maps out the split, highlighting the browse sub-algorithm, optimized to serve a calculated mix of familiar subscription content alongside personalized discovery recommendations. This contrasts with the suggested sub-algorithm, which operates on entirely different triggers, optimizing for deep topical continuity. The suggested algorithm balances the rabbit hole effect, feeding highly related videos to maintain momentum, with occasional watch something else resets to prevent topical burnout. Aligning content with these specific behavioral triggers provides a measurable advantage in capturing long-term audience attention and achieving consistent channel growth. When channel momentum suddenly plateaus, many professional creators assume they have been artificially restricted or shadow banned by the platform. Consider a specific gaming channel with over 5 million subscribers. Despite high production value and an established audience, their videos were inexplicably underperforming. The creator assumed the algorithm was actively suppressing his videos. However, a close analysis of the behavioral matrix revealed a simple data conflict. His upload schedule was misaligned with the hours his specific audience was actually online to click. The precise intervention was purely mechanical. The creators shifted the upload timing to early morning, aligning the video's initial release perfectly with the real-time availability of his core demographic. This line chart tracks the channel's performance metrics following that single variable shift. The stagnant numbers violently spike upward, registering an additional 64 million views over a 28-day period. When professional content fails, it is rarely a glitch in the code. It is a failure to align creator strategy with the audience's behavioral data pipeline. The entire machine learning architecture functions as a massive, continuous pipeline, taking raw video files, pulling them through the metadata intake pipeline, testing them in the satisfaction feedback loop, and distributing them through the sub-algorithms. This system is blind to ego. It does not care how much effort a video required. It only responds to retention, viewer satisfaction, and clear semantic packaging. Strategists looking to succeed must strip away superstitions. They must stop fighting the system and start viewing their content as raw inputs for a deep learning machine. Become a student of the data. Actively analyze your own negative signals, locate the points of abandonment, and course-correct your strategy based on objective metrics. The YouTube AI functions as a highly sophisticated audience matching engine, accessible to anyone who provides the right behavioral inputs. It is ready to be engineered.